Assalamualaikum warahmatullahi wabarakatuh. Okay, we continue our discussion regarding on diastereomer. What is diastereomer? Diastereomer are stereoisomer that are not mirror image of one another and are non-superimposable on one another. So diastereomer is different with enantiomer. Okay, in enantiomer, the object and image is superimposable and non-superimposable. Okay, stereoisomer with two or more stereocenter can be diastereomer. So there are at least two stereocenter or two chiral carbon for diastereomer. If only one stereocenter or one chiral carbon, so there is no diastereomer. Diastereomer must have at least two stereocenter or two chiral carbon. Example, if you look at this is 1, 2, 3, 4, 5. 5 is pentane, yeah. Pentane, 3 methyl 2 hydroxyl pentane. Okay, this is one structure, and another molecule is the different molecule is 1, 2, 3, 4, 5. Yeah. Also 3 methyl 2 hydroxyl pentane. But this is the connectivity is the same with carbon, but the difference is the arrangement of the groups OH or CH3 on the space. Arrangement on the space. Okay, so let's say this is object. This is the line here is considered as mirror. Okay, so OH, the position of OH is moving towards you, but this is wedge, and CH3 also moving towards you. Okay, so H at the back, this H at the back. Okay, and then molecule B, if you see here, OH is the bonding is wedge, ball, and the CH3 is dash on the other side. Okay, if you look at this structure, this is object, this is image. Assume this is image. So if you have CH3 overlap, CH3 object, CH3 image. Okay, this one also the same. CH2 object, CH2 image. This OH also the same. OH object, this OH image. It's also the same. It's also the same. But how about the methyl group here? Okay, you look at this structure, CH3. The orientation of CH3 is moving towards you. We call ball or wedge. The color is of this bonding is ball. So this is moving toward you, but this image, the orientation on the space is another side, quite far from your eyes. So on the other side. Okay, so this is object, but this is not their image. Okay, if image, this should be ball or wedge, but in this case, the structure be CH3 on the other side. So on the first rule, for sure this is not considered as an enantiomer. and then this is a diastereomer. And then if you try overlap, is no non-superimposable or no overlapping with their object. Okay, so there are two criteria to determine either this is enantiomer or diastereomer. For diastereomer, first of all, the image is not their mirror of their object. Okay, and then second one, both of molecules non-superimposable. Okay, similar goes to this structure. If you look at this, so here you have 1 to 2 chiral carbon or 2 stereocenter. So there are the possibilities to have diastereomer isomer. Okay, this is 1, 2, 3, 4, 5. 5 is pentane, 3 methyl, 2 hydroxy pentane, but this is different configuration. Okay, molecule A and molecule B. You compare, if you at the first glance, you cannot determine the diastereomer because you have this is CH3, this is CH3, this is CH2. But this on the other molecule, this is CH3, but this one COH. So how can you arrange this molecule in order CH3 goes to this side? Okay, so you can flip or you can rotate this molecule around 180 degree. Yeah, just rotate. You can imagine CH3 goes to here. Okay, CH2 other next to CH3, and then followed by this one. Okay, follow this, and then CH3 on the other side. But if you flip 180 degrees Celsius, meaning that this OH will turn to, at the beginning, this is dash. If you flip 180 degrees, this become wedge on this side. And then this also methyl group become dash on the other side. Okay, so if you compare, this is not the mirror image of this object. So this pair of diastereomer. Are you clear, class? Can you follow me? Okay, we can look at another structure here. The stereoisomer of tetratic acid. Tetratic acid have 3 isomer. This is 2R, 3R tetratic acid, 2S, 3S tetratic acid, 2R, 3S tetratic acid. Okay, I think we can have a cam draw here. Can use cam draw is much more to more better for you to understand this one. Okay, this is first structure as mentioned before. This is second. This is third. Okay, this is first structure. Okay, this second. This third. Okay, class. Is 3 stereoisomer of tetratic acid. Yeah. Okay, by definition, diastereoisomer, on the first rule, you must remember that image is not mirror image of their object. If you compare structure number 1 and number 2, okay, this is COH, OH on wedge, OH on wedge, so moving towards you, and then this is COH. This is dicarboxyl acid. Yeah? This is mirror image. This is mirror. Okay. But this structure, okay, this going down, is it COH? So you have to okay, in order to bring to get the similar position of molecule 1, so you have to, okay, this is not the same, not the right position, because COH on the other side. Okay, okay, what you have to do is you rotate 180 degrees Celsius, sorry, 180 degree, so bring this to here, to the left side, and right side you bring to the left, sorry, right side bring to the left, and left bring to right. Okay, how about if we turn like this? Okay, so this is become OH. Okay, this is double bond. Okay, it's OH, it's double bond. Okay, then follow this is, okay, we bring it down here. Okay, is CH, CH, OH. Okay, if you flip 180 degree, so this become, this is dash, and then this become wedge. Okay, become OH. Okay, and then this is CH, the bonding here. Okay, then C at the beginning is dash, so this become wedge also OH. Then this is carboxylic acid. So here, if we turn to 180, flip to 180, degree. Okay, but this is still structure 2. Still is, it is the same, but just rotate. Rotate the structure. So if you compare structure 1 and the new, after you rotate 180 degree, yeah. So here, this is, okay, I think we can bring it down. Okay, this is object, and then this is image. Just compare. This is object, OH image. So here we bring the mirror going down, and then OH on the same direction, same orientation. OH, OH, this is image, this is object, and then the rest, this OH is object, this is image. So what can you see here? So on the first rule, this number 2 is the image of number 1. Okay, and then if you bring this molecule, you try to bring together and try to overlap, you will didn't get the overlapping structure. So you just get this is non-superimposable. So this number 1, okay, what we can see here, number 1, structure number 1 and 2 is pair of enantiomer. And okay, pair. Okay, class. How about if we compare structure 1, okay, structure 2 and structure 3. Okay, I think we bring it down here. Okay. Number 2, see here. This is object, this is image. Okay. If you try to rotate structure number 3 in order to get the same direction of this one, COH, because this is up, this is down, so just rotate here, you'll get carboxylic acid on this side. This is O, and then this bonding, sigma bond, and then okay, this is dash. Okay, if you turn 180, this become whole OH. Okay. And then this is OH, which, so if you turn, this become dash OH. Then this one is carboxylic acid. O H. Okay, it's resulting after you turn 180 degree. Okay, class. So this structure number 3 is the same structure number 3. Okay, just compare with structure number 2 here. Okay, this is mirror. This mirror. Okay, this is object, this is image. Object, image. Object, but this one is dash, but here image is wedge. So on the other side, so if you see here, this is not the mirror image. Okay, so on the first rule, so here it's not considered as an enantiomer. This is pair of diastereomer. So number 2 and 3 is pair of diastereomer. TE. Okay. So we have one enantiomer, one diastereomer. We can compare structure number 1 and number 3. So this number 3, Just copy, then paste, because we want to check after rotation. So if you see here, number 1 and number 3 after rotation, okay, so this is object, this is image. This is object, yes, it's correct. This is image on the same direction, which moving towards you. But this one object, this one image. Image on the other side, yeah, the dash, OH, moving towards you or which. So this is not considered as enantiomer. This is pair of diastereomer. So number 1 and 3 is pair of STEREO diastereomer. Okay, so we have here two, the enantiomer 1 and 2, and then the rest 1, 3, and pair of molecule 2 and 3 is diastereomer. Okay, class, are you clear? I have another example here. Let's do it together. So this is 1, 2, 3, 4 butane, yeah, 2 bromo, 3 chloro butane. Okay, and then we have 1, 2 stereocenter or 2 chiral carbon here. If you want to check structure to name, 2s, 3r, 2 bromo, 3 chloro butane. So this is one isomer of bromo chlorobutane. This second isomer, third isomer, and fourth isomer. So here we have to determine which one is considered as pair of enantiomer and which one is considered as pair of diastereomer. Okay, if we compare structure 1 and structure 2, okay, just put mirror here. Okay, object, image. So CH3, CH3 image, BR, BR image, CL object, CL image, CH3. So number 1 and number 2. Number 2 is mirror image of object 1. And then if you bring this molecule, just bring together here. So you'll have this number 1 and number 2 is not overlap each other. Non-superimposable. Because BR will overlap with H. H will overlap with BR. So this is structure number 1 and 2 is enantiomer. Pair of enantiomer. Okay, number 3 and 4. Just bring down. Okay, 3 and 4. CH3 object is image. H object, H image. BR image. CL, CL image. So number 3 So number 3 and number 4 is enantiomer, pair of enantiomer. Okay, class. How about if we compare number 1, just copy, paste, section number 1 and number 4. Okay, number 4 here. Copy and paste. Copy, paste. Section number 4. Okay, draw the mirror here. Okay, CH3 object, CH3 image. BR object, H image. Okay, let's say you want to arrange in order BR is going here, H is going other side to meet the characteristic of their image here. For example, if I turn it 180 degrees Celsius, 180 degree, sorry. Oh. Okay, what happened here? Okay, just redraw. CH3. And then okay, we flip 180 degree, so BR become the other side. BR. So other side is proton, hydrogen. Same goes to here. Is BR. This is Cl. This is CH3. Okay. If you compare this object and image here, just bring down. Okay. Yes, this is object, image. This is object, this is image. But the third, the chlorine atom, this is object, is not the same. This is BR. Okay. So we no need for us to rotate because we didn't get the it's the same. Didn't get the enantiomer. So just leave it. So CH3, BR, H can overlap. So this is the first characteristic. So this is not their image. This number 1. Sorry, number 1 and number 4 is pair of diastereomer. STEREOISOMER. Okay, class, are you clear? Same goes to if you compare number 2 and number 3, so pair of diastereomer. Okay, I hope you can understand this one. Okay, we have discussed enantiomer, diastereomer, and identical molecule. So I want to explain a little bit about the meso. Okay. So another type of molecule is meso compound. Meso compound must have at least two or more stereocenter or chiral carbon, but superimposable with its mirror image. Can overlap, but superimposable with its mirror image. For example, this is epoxide. Yeah. So how many chiral carbon here? How many stereocenter? How many chiral carbon? Number one, number two. Okay, if you look at the structure, if you draw the line here, okay, line here, like if you put mirror here, so this is object, this is image. It's object, image, object, image. So this is superimposable. This type of molecule is considered as mesocompound. Same goes to this cyclohexene epoxide. Yeah, this is first characteristic you must identify. This is having two stereocenter, 1, 2, and then you draw or you put a line act as a mirror here. Then you check, this is object, this is image, object, image. It can flip, flip between up and down. Same goes to here. Okay, it's also considered as meso compound. How about if the structure is like this? Cyclohexene, but I put that butyl here. Okay, is it meso compound? So the first characteristic, you have one chiral carbon, second, and then third chiral carbon. First characteristic is achieved. Then if we draw mirror, if we draw line here, indicated for mirror here. So this is, let's say this is object, this is object, image. This is object, but this is, if you flip, this is not the same. This is just CH2. So if you flip, this is not the same. You will not get the mirror of the object. So this is not considered as meso. Okay, class. Specific rotation. Specific rotation. So for this is the symbol specific rotation alpha for an optically active compound. How to determine the specific rotation? Is the formula observed rotation. Basically, you will see this value using polarimeter, yeah, and divided by path length and concentration of the sample. Okay. So the specific rotation is the observed for 1 gram per ml in a solution cell 10 cm path. The length of cell is 10 cm. Okay, if you have enantiomer product or enantiomer excess, so you will not get the zero. The optical rotation value is not zero. Yeah? More than zero, more or less than 0 or negative. If you have a racemic product, so optical rotation is 0. Yeah. Do you still remember what is racemic product? You have 50% of positive configuration and 50% of negative or R configuration. So this is balanced. So that's why you will not get the value. You just get 0 for racemic. So this is racemic measure. You'll have the value of optical rotation is 0. Okay, this is polarimeter. The instrument used to determine the optical rotation of certain organic molecule. Okay, class. I think we end of this chapter. Next, we will discuss on reaction in alkene, especially for especially involving radical reactions. Okay, after this, I will give you tutorial 1, and then you can do it. Yeah? And we will discuss later. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.